think with no further ado, I would like again to welcome everyone to today's webinar. We are pleased to have Volker KREY here with us. He's a researcher, group leader of the Integrated Assessment, Modeling and Climate Change Group belonging to the Energy, Climate and Environment in IAMS. And since 2018, he's also a professor at the Technical University of Norway for Science and Technology and TNU. Volker is graduated in physics in 2002 and has a PhD in mechanical engineer from Germany. He's a long-time expert on integrated assessment models, data collection and data management of scenarios. Volker participated in several international assessment reports, such as in the Working Group 3 for mitigation of IPCC in the AR6 in Chapter 4 on near and midterm mitigation pathways. He also participated in the Global Energy Assessment and in the Special Report for Renewable Energy Systems. And for 10 years, Volker was also an editor of the Journal for Climatic Change. So with no further ado, again, Volker, thank you very much for being here, and the floor is yours.
Yeah, thank you, Joanna, for the kind introductory words, and yeah, actually to the IAMC for this opportunity to do a bit of a give a bit of a backward-looking perspective on the development of the data infrastructure of the Integrated Assessment Modeling Consortium. Let me just set up screen sharing so that I can start presenting material. I hope this works. So, yeah, as mentioned, I will look back basically over the last almost 15 years to recollect how the development of the IAMC data template came about, which ended up becoming, I think, a bit of an enabler for doing model intercomparison studies, as well as reanalysis of larger community-based scenario data sets, because it simply lowered over time the threshold of allowing to collect and systematically analyze these data sets. Most of the presentation I'll spend looking back, the challenges that the community faced at the time, then giving an overview of the original development, look at some revisions and extensions that happened over time, then very briefly go into the complementary development of the scenario databases and scenario explorer infrastructure, look a bit of applications, and then take stock where we stand, basically also looking at challenges and issues that we are facing, and proposing, also looking into new ideas how to overcome these challenges based on a process that was started at the last 2022 annual meeting. I should say here, the work that I'm presenting on the one hand, is a personal perspective. So yeah, some of the things that I'm presenting may have been perceived by others. What is important to note that there is a lot of people who've contributed to the process, some of which I will call out, in particular the group that was involved in the original development, and then a few people specifically at YASA who've been super important in terms of operating the infrastructure and making all of this happen. There are many other people who have contributed who I won't be able to specifically name here. That's just important to keep in mind. So let me start taking a look back. Roughly 14 years passed since this whole process started. We basically faced a situation where, after completing the 4th IPCC assessment cycle, there was an increasing number of model intercomparison projects and exposed scenario studies. When I say exposed scenario studies, was basically people were looking for existing scenario data to include in reports that were prepared and the analysis that was done. So basically allowing reanalysis of previously conducted scenario studies. Typically, every study used its own data template for collecting the data. So there was long versus white table formats, different variable names. The headers were all different. I'll show you a couple of examples, which I was digging up from my archives. This was basically the time, first couple of years after I joined the integrated assessment modeling community at IASA. And so a lot of these requests ended up on my desk, which ended up creating a bit of workload, and also at some point gets annoying if you have to basically reformat the data that you've previously shared already just to make the format fit. So there's a couple of examples, and don't get me wrong here, I'm not criticizing those studies. It was just the practice at the time, and they were important to basically pave the way to where we are now. Here's an example from the Energy Modeling Forum 22 study. Internationals explore the international scenarios of EMF 22, explored near-term inefficiencies in international participation on transition towards stabilizing CO2 equivalent concentration. So a research question that you would still is still super relevant today. You can see there's some similarity of this data template with what we are currently using in the integrated assessment modeling consortium. So it's basically a white table format with the years here. There is a variable name. There's a few additional columns that basically categorize the variables in terms of how important they are. There are nodes, categorization scheme is included. The names are somewhat similar, but not totally. As a model column, there's the scenario column basically has been split into 3 to categorize them. And then what was also typical at the time is you basically had tabs for the scenario at a time in these spreadsheets. This is another example of a study organized by the National Institute for Environmental Studies in Japan, NICE at the time. So they were looking after how mitigation potentials are different and why they are different across different studies, and basically getting insights in how to better compare them. Here the situation looks a bit different. You have a quite extensive header, including some information on how to use the template. And this was specifically for emissions. So if you wish, the variable was split into 2 fields here, sector and gas. It ended up being a long table format. So there is a year column, and then multiple scenarios that indicated the mitigation potential were basically in different columns. And there were again other types of data that came with this format across different tabs. Another example from a study that had similar objectives. You can see there is a pattern. In some degrees, it's all similar, but it's never that similar that you could just use one data set to feed the other, or one template in exchange of the other. Another one, this was for the World Development Report of the World Bank in 2009, where they were looking for scenario data. This looks already very similar to IAMC, with the exception that the scenarios aren't listed. The scenarios are basically in tables that are below each other in a spreadsheet. So there's no separate column for that. The model isn't indicated here. That's on a separate metadata format. So again, all similar, but not similar enough so that you could basically automate or basically reuse the same data. That was essentially the starting point, and luckily at the time, the Integrated Assessment Modeling Consortium had been formed to coordinate these efforts. And at the second IAMC annual meeting, which was held in September 2009 in Tsukuba in Japan, basically the annual meeting was held back to back with the kickoff meeting of the Asian modeling exercise, which was coordinated by colleagues at P&L, most notably Kate Calvin and Leon Clark. And they were basically facing also this issue. And it was essentially taking then as a starting point to form a small working group to establish a first version of the IAMC data template, where the AME took a pioneering role for testing this first data template in combination with an accompanying scenario database infrastructure that was set up at YASA based on some earlier internal efforts at YASA. And then basically the year later, EMF 24, so Energy Modeling Forum 24, that included both a national and an international component, followed, and basically also started using this data template, which was of course important to generate some critical mass around the usage. So that's the working group that was set up. Important roles here played Kate Calvin and Leon Clark at the Joint Global Change Research Institute, simply because they were in the driver's seat for the AME, which was the major content driver. Then also Tatsuya Hanoka and Mikiko Kainuma at the time at NICE played a very critical role. They had organized the scenario data collection in the fourth assessment report cycle, and therefore had to provide important insights. And then there were a few colleagues from YASA, including Kevan Riai and colleague Peter Kolb, who was basically the person behind the scenario database infrastructure at the time. And then Bas van Rijven at the time still at PBL completed the group. And so shortly after the IAMC annual meeting in October 2009, we started having first calls and dished out a template specification and first sets of variable and region definitions, which were essentially driven by the Asian modeling exercise needs immediately. So some of the requirements that were put together was we wanted to create something that is easy to use for both data suppliers, so the modeling teams that need to provide utilize the data, as well as the data analysts that essentially then look through the data, also need to make checks for errors and internal consistency and so on. We didn't want to completely reinvent the wheel. So the idea was to be close enough to existing data template structures, some of which I showed you before, so that that would be acceptable for use in the community. We also specifically wanted to keep the entry barrier very low, so that someone, a modeling team that would just use this once to join the study, wouldn't have to sit down and basically create a lot of automated code and tooling to be able to use the structure. Then it should of course be machine writable and readable, so that one was in the position to automate processes, as well as being highly adaptable to the needs of future modeling intercomparison projects and data collection efforts. And again, and this relates to the one-time versus many-time use, suitable for both small and large-scale applications. So processing with simple tools, you could essentially still do some things in spreadsheets if you had just a couple of scenarios from a couple of modeling teams, or databases or more sophisticated tooling. This is a flowchart that I ended up finding in one of the meeting minutes that we created, basically suggesting a 3-layered approach with what we at the time called a data container. So that's basically a file format that would include information on meta information on the data set, so some metadata, the actual time series data, as well as the possibility to deposit also comments. Then there was the idea, and you see this here in blue on the right-hand side, to have basically a standardized set of variables, relatively lean. So you could think about it as a core variable set, such as primary energy, final energy, emissions, and so on, from the IMC, and then complemented by application-specific variables, but also possibly regions and so on. And those 3 building blocks would then, in combination, make a specific instance or an application version of the data template. I think in the end, this is where we are, where this regularly reviewed and updated standard variable set and standard region set is something that we've a bit lost track of over time. And that's something that I'll get back later on towards to see how we can improve the management of that. In terms of specifications, we looked at alternative file formats, including also more sophisticated or advanced formats that, from a technical perspective, seemed actually quite attractive at the time. XML-based formats, something like XD, other type of formats, which I don't even remember today anymore. We ended up not going down that track because it would essentially the fear was that we would, excuse me, sorry, I had some issue with the mic setup. I hope this is now resolved. So the fear was that these more sophisticated formats would essentially create a large entry barrier for teams that would just start using the format, and therefore we dismissed that at the time. Then non-proprietary formats were, of course, high on the agenda also then. Comma-separated value files were a solution that we looked into. We also dismissed that because of problems with potential problems with different decimal separators in different regional setups of computers, problems with quotation marks. So we do use comma-separated value files actually for the exports, the so-called snapshots that we produce in model intercomparison projects, where we have full control of how these files are structured. But yeah, the fear was that using those on the input side could potentially lead to significant problems. And in the end, we essentially used what many other templates that I showed you before had been using, essentially allowing different versions of Microsoft Excel spreadsheets, which ended up becoming the least common denominator. In terms of flexibility, you've seen that some of the earlier templates had a multi-layered or multi-level structure for either variables or scenario names. And that was, of course, also something that was discussed at the time. In the end, we essentially went with just one layer or one level, let's say, translating into one column for each of these in the data template, and used a separator for which the pipe character, which usually doesn't appear otherwise in strings, was used so that we could essentially had the flexibility to use any number of levels that were required without having to agree a priori on 2 or 3 or 4 levels that may at some point in the future might have been inappropriate. And then, of course, flexible time steps and years were also an important consideration. So while at the time the AME, the Asian modeling exercise, used 10-year time steps, of course, we have now many applications that use 5-year time steps, annual data, or a mix of them, and all of that is possible in the template. So all of you know what, I assume all of you know what came out of it. This is just how one instance of the time series dimension of the data set looked like. I won't talk much about it, but instead move on to metadata, which wasn't initially picked up, but then a couple of years later, in particular in the preparation of the 5th assessment report, where a lot of scenarios from different model intercomparison projects and individual scenario studies came together. It was much more important to basically get structured descriptors of the data sets to be able to systematically analyze them and make sense out of them. And for that reason, there was an attempt to introduce model-specific as well as scenario-specific metadata, including opportunities, or including characteristics of the model, type of model, what type of cost metrics it can produce, what type of technologies are represented, and then there's scenarios indicating, okay, was this a scenario part of a bigger exercise? Is it a baseline, a climate policy scenario, diagnostic scenario, and so on and so forth. So potentially very long lists. In the end, I'll come back to that a bit later. From my perspective, the whole metadata definition process has been not as successful as we would have liked to see it, simply because in most individual studies there was little effort and incentive to do this, because in particular the scenario dimension is coordinated in each individual study, right? How the baseline scenarios are constructed, how the different mitigation scenarios are constructed. So there's little effort to, in addition, generate these scenario metadata. On the modeling side, it's a bit different. There was a bit more interest, and that would also only need to be done once upon registering models if a scenario database or scenario explorer was used in the effort. I'll talk a bit more down the line. In terms of bigger revisions and extensions of the data set, of the data template, there was very early on a change in nomenclature where the total that was present in many of the sub-aggregates of specific categories was removed because it was considered to be redundant. So for instance, primary energy type total was replaced by primary energy, essentially introducing the assumption that if there's nothing there, then it is a total of that category. Then around 2015, a revision of emission variables was introduced, which was driven by a process to harmonize emission categories in the shared socioeconomic pathways for use in CMIP6, so by the climate and earth system models. And in that process, the definitions were basically were based on IPCC national emission inventory guidelines, which is also useful because it allows more closely connecting scenario data with actual statistical data. More recently, as part of the Navigate projects, there was an effort to revise, for example, final energy variables, separating out non-energy use and bunker fuel use. And this should have been a separate line here, reporting of gross carbon flows. So taking into account, not only net removals, but gross removals more consistently was introduced here. And that's something, again, to be picked up later on in the challenges, where typically these innovations are driven by, or these revisions are driven by individual project needs, but we basically lack a process to then propagate, to consolidate those revisions and propagate them to other projects. This was much earlier in the early stages of the use of the template, simply because there were relatively limited number of applications. Has become more challenging now. In terms of extensions of the template, there's of course countless variables that have been added, and that's again contributing to the challenges. In addition, there was one effort that structurally basically revised, and this is only what I'm aware of. There might be other extensions that I'm not listing here, but a European focused project that included energy system modeling groups, including those that have a lot of detail in power systems modeling, basically introduced an innovation to add sub-annual time slices, so allowing to use this template with whatever seasonal or potentially also hourly resolution of time series data. And that's, I think, something that many people may not be aware of. Then, of course, part of the story was also that in addition to standardizing the template, a bit of tooling was introduced by the scenario database or Explorer infrastructure that IASA is hosting on behalf of the Integrated Assessment Modeling Consortium. So basically having an interactive web database with user and group management. Originally, the more management or administrative features had to be done by someone at IASA, but in the meantime, this has been automated to a degree that actually also other institutions or colleagues from other institutions can actually, to a large degree, administer and run those scenario databases independently. I think one primary feature, importantly, at the very beginning was the automated aggregation to standard regions that one could compare on. For example, the 5 regions used in the Shared Socio-economic Pathways, or 10 regions that have been used in a number of model intercomparisons, and so on, as well as the 6th assessment report of the IPCC. Then this introduced the possibility to also introduce some automated quality checks, so model and variable and region names actually consistent with the definitions of the study. Is the base year matching within the base year data for some variables matching specific statistical data sets. More recently, a check was introduced to whether subcategories of variables actually add up to the totals. Some effort has been put into this, but again, I'll come back to this in a bit. There remains a big challenge and a lot of potential for improving on this. Then there is the possibility to download database snapshots, so consolidated data sets, and of course, in the end, data visualization, dissemination to the public is an objective of these tools. So for the first 8 or 9 years of the whole effort, we used this scenario database infrastructure seen on the left here, and then since 2018, transition to the newer Scenario Explorer infrastructure was taking place. This is a list of applications that I'm aware of, and those are mostly those that have databases or scenario explorers included or in the making. There is presumably for the data template a much longer list, but that is of course much harder to keep track of because there is no need to centrally coordinate on usage of this data template idea. But as you can see, it's many studies at the global level, at regional levels, at country levels. So has been a lot of activity. And then let me also say a few words about, and this is now more related to the databases, showing you a bit of access statistics over the last 10 years. So this includes the IPCC data sets, then SSP, RCP data sets, but also individual project databases. I'm listing here one that recently has gotten quite some prominence, the so-called Network for Greening the Financial System Scenario Explorer, with database for the financial, scenarios for the financial sector. And as you can see, there has been a steady growth of monthly visitors over the past 10 years, starting at very low levels back in 2012-13 when the whole infrastructure was launched. And now we stand at roughly 20,000 unique visitors across all of these instances per month, with quite significant download volumes, at least when considering that these are only time series data, which as such are not very storage space intensive. You can see here also some of the spikes in the access statistics actually relate to the release of important reports. I've indicated just a few here, like the IPCC data sets. What is worthwhile noting that the financial sector applications have or are gaining a lot of user attention. And you can see that even at this relatively large set of instances, they do leave a footprint here. Most recently, the NGFS phase 3 scenario data set that was released in autumn last year. So that's basically where, what has been happening since the onset of the data template and scenario database infrastructure development over the past 14 years. I have two slides on taking stock. One is talking briefly about the challenges and issues, and I had already identified a few or pointed towards a few of those throughout the talk. One challenge that we are frequently facing is that there is no strict hierarchy in the variable names. There is ambiguity. If you think of, for example, final energy, you can break down final energy by fuel or by sector. And if you do the combination of fuel and sector, then you could do it either by sector and fuel or by fuel and sector. So there is a kind of by construction some ambiguity of the ordering here, which basically means one cannot, based on just the scenario names, on the variable names, it's not possible to create summation rules. What needs to sum up to what? So one essentially needs to complement that with additional information. One of the reasons why this hierarchy wasn't introduced strictly was that you could end up, if everything is hierarchical, then you could end up very quickly with very, very long scenario, with very long variable names, which, isn't also particularly attractive when using those data sets. But that's something, to be tackled in particular for consistency checks, and something we come across quite frequently. So we are at the moment lacking this central approval instance for new variable names, which basically means that we have a number of incompatible variable extensions used in parallel, which in particular becomes a challenge then when bringing these together, as for example, in the IPCC assessment scenario data sets. I already mentioned earlier that the metadata never got fully picked up, as it is mostly interesting for assessments. And therefore, there's a lot of manual effort and nudging required in those assessments to essentially gather this these metadata on top of it, because they usually don't exist from individual studies, and therefore require manual effort by teams, which is of course not very attractive. One thing that the data template in principle also supports, but what isn't used really extensively, is a comment functionality that would allow, for example, documenting also non-compliance with certain definitions. In some cases, it's just not possible because, let's say, a model doesn't fit to the definition that is given for a specific variable. But very few modeling teams actually make use of this comment functionality to document these deviations at least. And then we in the end find out, okay, some data are not necessarily compatible with each other without knowing this a priori. And despite quite some efforts having gone into automated quality control, there is still large gaps. Limited variable sets are automatically quality controlled, such as emissions, energy, and so on, but others are not. And one challenge is because of regional definition differences across models, often these automated quality control checks are only implemented at the global level, which is again a challenge that can be overcome, but of course requires quite some effort, because one would always need to essentially create the statistical data sets or aggregate the statistical data sets to the regional definitions of a specific model for this to be meaningful. On the plus side, we see that there is a number of tools being used or that have been developed around the whole data template, around the whole data template, allowing to more efficiently use it. Predominantly, this code or these packages and tools have been developed in Python and R that are widely used in the integrated assessment modeling consortium community. I would argue there's potential to push this even further, but definitely we see some very promising developments here, and also pickup of some of these tools that are being used and developed in this context. But more is definitely needed. That brings me to the last section, and I'll wrap up in a couple of minutes. Importantly, as a way forward, following the last Integrated Assessment Modeling Consortium annual meeting at the University of Maryland, end of last year, 2 new scientific working group co-chairs have been appointed. This is Ken Oshiro at Kyoto University and Jessica Streffler at the Potsdam Institute for Climate Impact Research. And I think that is a very important step, because it will allow us hopefully to have more resources and more capacity to tackle some of the challenges I sketched out earlier on. We have had a call with the new group of co-chairs, and what we want to do is basically establish subgroups that essentially maintain sections of the variable sets independently, because this has become an extremely large effort with tens of thousands of variables that have been essentially constructed or defined across all sorts of applications. But of course, there's also some coordination between those subgroups important or required to ensure that basic concepts and also where it comes to intersections across different sections of the template remain consistent. And then related to that, we would like to establish repositories and further develop tooling for maintenance of the IAMC data template infrastructure, so that there is in the end a central place where agreed upon variable names, region names, and so on can be taken from, and ideally over time in a user-friendly way, so that you don't need to do lots of coding for allowing to use those data sets. Related to that, we are very eager to if you are interested, we are very eager to set up these subgroups relatively soon. There is an idea or a first proposal of how to basically slice the responsibility across the template for maintaining these different sections, which are shown here. Some of them we have basically tried to make this a compromise of sections that closely relate to research interest of individuals. For example, the end-use sector, energy end-use sectors, industry, buildings, and transport are individual sectors. So if researchers have a specific interest in those sectors, they may be more willing to take responsibility for maintaining also the variables in this in these sections of the template, simply because it will benefit their own research. Same is true for the emissions level, then energy supply accounting, so primary and secondary prices and so on, and macroeconomy. But again, this is a first proposal, and we will reach out shortly to the community to basically start this process. And again, if you are interested in contributing here, which would be very much appreciated and valuable to the community, then we are more than happy to facilitate that. And yeah, so please get in touch. That brings me to the end of my presentation. I mentioned earlier on that there is a lot of work that has been put into this by individuals, and I will unfortunately not be able to acknowledge all contributions. However, I felt I have to at least acknowledge a few colleagues at IASA who've been putting a lot of effort, in particular into the maintenance and development of the scenario database infrastructure, and related to that, then also to make sure this works smoothly with the template. The colleagues are listed here and have also taken responsibility for some of the data sets in the IPCC assessments in particular. So yeah, let me just highlight that here. Without all of this effort, I think this whole procedures, the data template, and also the community data sets would not be where they are now. And with that, let me conclude my presentation, and thank you for your attention.
Volker, thank you very much for your comprehensive presentation. Very exciting to know the backstage and historical background of the tremendous evolution over time to make the community a bit more transparent and support the challenge that we are facing. So now I'd like to invite all participants to write down under the Q&A chat some questions, clarifications, comments you have for Volker. But before open the floor for the public questions, I have myself a few questions, Volker. So in your view, you mentioned in one of your slides, challenge and issues. And in your view, thinking ahead, for instance, in the IPCC 7th assessment cycle that will start after elections in July, what are, in your view, the major challenge ahead, and how we can support you and the entire community to improve those?
Yeah, thanks, Joanna. This is, I think, it's a key question. I think one of the insights from the 6th assessment report is that it's becoming, because of the large number of data sets and studies, it's becoming more and more challenging to actually do this, these comparisons and the data collection as part of the assessment itself. So from that perspective, it seems important as a community that we're more proactive in terms of essentially doing some of this work more continuously, to enable then feeding into some of these assessment reports. I mean, the IPCC assessments are of course a key customer, let's say, for that, but there's others. I mean, for instance, the UNEP GAP report typically uses integrated assessment modeling scenarios, and that comes out annually, right? So they can rely close to IPCC assessment reports on the IPCC data sets, but then there's additional effort bringing on further studies. So from that perspective, the whole data management becoming a more continuous activity would be important, acknowledging, of course, that this requires resources, right? And this might not, I mean, that's something we have to think about, and hopefully can work with funders to allow, providing these resources for allowing to do this in a more continuous mode.
Yeah, thank you very much, Volker. I see we have a few questions in the chat. There's 2 questions from Claude. And let me read aloud here the summary for those. Claude wants to know what models say about climate damage and their overshooting pathways. He mentioned about the ecological collapse, so probably he's talking about impacts. And the models you present and the pathways are related to mitigation, where you may want to further develop on this.
Yeah, I mean, that's of course a question that goes deeply into substance. And there are definitely studies, and I mean, I should say that, I mean, I've been working with land use models and those that then more closely linked to food and biosphere development, but that's not my main field of expertise. But there are studies such as ACMIP, and others, there's the Bending the Curves study that was published a couple of years ago, which have much more closely looked into into those dimensions that are here listed. Let me not start getting into the substance, but I think it's a worthwhile point, and in a way, if you look back at the template and infrastructure development, we started out really with more energy-focused analysis and comparisons. I mean, the Stanford Energy Modeling Forum has the energy also in its name, but of course, in integrated assessment modeling, the land dimension is very important as well, and there's maybe more to do in that sphere as well, also to bring over data sets from some of these studies that have a land focus and a biospheric focus into these data sets.
Yeah, thank you, Volker, for your clear question. We have a couple of more questions. One comes from Ed, and he suggests including additional working groups to develop further metadata or regional assessments. So you may want to comment on this.
Yeah, Ed has been in this very painful position of managing the 6th assessment report scenario data set, and there specifically the metadata has been a challenge, as I mentioned before, and I concur. I mean, there is definitely scope for adding subgroups. At the moment, we started basically out with the variable lists, which have become a major challenge to keep on top of, but I definitely concur that there is also beyond the time series dimension and keeping on top of the variables, there is definitely scope for other things, and the metadata is an important one. But I think beyond the definition side, it is important to basically find a better way of motivating modeling teams and also individual studies to basically collect and generate this metadata, which is then super useful in particular for larger scale across different model intercomparison projects, the type of analysis as typically done in the assessments. And I think, yeah, creating those incentives is what we've been struggling with in the past. But yeah, very good point by Ed.
Yeah, thank you, Volker. And then we have two questions related to variables. Seems to be a hot topic here. From Luis Bernardo from Synergia COPE in Rio, and Jan. Luis Bernardo asks about potential limits to increase variables if we go over 10,000 of variables. We clearly have a conflicting here. On the one hand, we want to be more comprehensive and more detailed in the assessment to be more transparent. On the other hand, we face computational conflicts. And Jan also relates, and he wants to know if there is a complete list of variables and their definitions. So that's probably related to metadata as well.
Yes, both very important points to make here. On the one hand, with the number of variables, one needs to keep in mind, I mean, many result from basically unfolding the whole variable tree. For example, if you look at the SSP, database, which has very granular population projections by gender, age cohort, education level, and yeah, so that essentially, that basically means you can have very large multipliers that then end up for one category having 1,000 or thousands of subvariables. So that leads to this very large number. Then it's important to recognize that, of course, not every study is interested in every set here. So this granular population data may not be so important to collect in a technology-focused scenario comparison. So clearly, we need to manage this and make sure that we don't overburden also the modeling teams related to that. One attempt that we're going to implement is basically a prioritization or assign more consistently tiers in terms of importance to different variables, so that high-level variables that we basically create an incentive for all studies collecting a core set, which will then allow also comparison across different studies, while other variables are classified as lower tier, lower importance. Yeah, that will at least give some guidance on what to prioritize from a broader community perspective. But yeah, it is important. Then the second question related to this collection of variable extensions or variable lists. There have been over the past decade or so, I think, a couple of attempts to create what we called at the time a super template, basically that brings everything together. Those ended up getting never completely done because, yeah, it ended up being a very large effort. But exactly the establishment of the subgroups, the idea is there to probably will go with GitHub repositories that contain then these lists by template section or by template subgroup, to basically have one centralized point of contact when designing a new variable template, where to start from, instead of having to guess what has been done or what hasn't been done. So it's a very important point, and this is exactly what we're trying to pick up as part of the subgroup effort.
Yeah, thank you, Volker. I agree with your point. Challenging ahead, where there's definitely benefits for improving the database and the metadata. We have two other questions from Scenario and the database users, one from Gustavo and another one from Paul. Paul wants to know if the database, how the database can be made more useful for PhD students. And he complains about the data in coding language that he probably is not familiar with. And Gustavo also wants to better understand what would be the use of data at the country level, for instance, in terms of extracting data related to climate financing and investments. So 2 questions from users of the database.
Yeah, both again, highly relevant. I mean, related to Paul's question, in principle, the data sets are not restricted. The access to the data set is not restricted to members of the integrated assessment modeling community. I mean, they're typically restricted during the course of conducting a study. So while they are still working data sets, then usually just the modeling teams that are basically involved with the study have access to it. As soon as the studies are finalized and the publications are out, typically those data sets are then made publicly available. The only thing, I mean, what we've in many instances done in the past is that you basically just need to register at the data set, at the database to be able to download. The reason being that we would like to inform users in case of updates on the data set, errata, and so on, which is quite relevant in particular in the IPCC processes. But there should in principle not be restrictions of who can access it, and specifically, yeah, PhD students or also can access and should be able to access them. If you have specific suggestions or struggling with finding or accessing the data sets, we would of course be very interested in getting your feedback to improve on that. And then related to the national data sets, I mean, I think this has improved over time. I mean, one needs to recognize that a lot of the groundwork in the early days was done based on global modeling studies. It has been now extended to national studies, so we need to probably improve there. But if you look, for example, at the 6th assessment report, Scenario Explorer, that actually features a lot of information also at the country level. I've specifically been working with those national level data sets for the NDC and current policies assessment in chapter 4 of the IPCC database. And again, we are far from comprehensive, and the situation can be improved a lot. But compared to the 5th assessment report, there's a lot more national level information included. And of course, individual national level studies, those data sets do also typically publish then the national level results, including national information from global models, but also information from dedicated national models.
Thank you, Volker. It's probably worth emphasizing that these exercises for data collection and manage are not developing new data, so reflects the latest available knowledge in science. So if some countries have a gap knowledge for scenario and pathways, we can't actually include those in the data creation exercise that we were describing in your presentation. So it's something worth mention about that. And to keep us on time, Volker, we have a last question from Hank. I hope I pronounce it correctly. It's about how to be more involved in the data protocol application and what is the deadline to do it.
Yeah, it's a good question. And I mean, yeah, we had actually a call going out back in January, I think, following the integrated assessment, the IAMC annual meeting. It took us, unfortunately, a bit longer to get started with the appointment process for the additional co-chairs now. We will get back to those who sent emails back in January and are more prepared now to move this forward. But if you, I mean, also feel very free to send me a note in case. Yeah, in case I overlooked something, which unfortunately happens at times. But we will also get back to those who sent information earlier. Again, apologies. Process took longer to set up than we had originally thought.
Okay, Volker, thank you very much. Since we are due to time we planned for this webinar, I would like once again to thank you for your clear presentation, comprehensive answers, and also highlight that we had more than 60 participants during your presentation. I control here in the participant list. So thank you everyone who attended to the webinar for the questions for Volker and for IAMC organizers, and looking forward to see you soon.